All right, hello everyone. Welcome to the Off by One security stream. Every time I see that countdown timer I put on, it makes me cringe a little bit, but it has to be something there to allow everything to connect to the different apps that we're streaming to. So apologize if that's annoying to you. But welcome this week. We've got Graham Helton and a session read only to RCE, discovering new Kubernetes attack paths. And I am looking forward to this one. I know a lot of you are as well. I've got a lot of DMs on Discord and such because a lot of us, including myself, don't really understand the world of Kubernetes. I myself have just never gone down that path, so very much looking forward to what Graham has to say. With that, I guess, Graham, could you give a little background about yourself?
Yeah, sure. So my name is Graham. I do red team things. I've been doing Kubernetes security for a little over 3 years at this point, which is kind of crazy. I started at my last job. It was kind of like a situation where I realized that there was a lot of value to be added by exploring Kubernetes, and then that was encouraged, and that's a dangerous combo. And so I kind of just went down the rabbit hole, and I don't think I've ever come back out. So yeah, I started doing Kubernetes security like 3-ish years ago, and then I've just been super interested in it. Anything from like the vulnerability analysis side of it to like finding new vulnerabilities to like more traditional like pen testing, like finding known issues with it. So that's kind of how I spend my time in regards to Kubernetes. Aside from that, I do a ton of other things. Mostly anything like Linux or Kubernetes related is kind of my happy area and where I like to spend my time. But yeah, other than that, I do red team things now, and I try to spend my time mostly in Kubernetes clusters.
Nice. Do you I guess is it similar to traditional exploitation, the kind of the research and stuff you're doing, or is it very, very different from like binary exploitation of web apps?
I think it's different, but it's kind of like the same mindset. I was actually thinking last night when I was editing the slides, I was like, oh, there's a lot of things that are like they seem very different, but it's like, oh, you're looking for like some sort of gadget so you could do this, and you're taking the same steps, just like a totally different environment. And a lot of it is very interesting to me because so much of it is open source that like you can just go clone the repository and be like, I think something weird's happening. Let me go check and see if it is. And so that's really, really helpful. There's no like, you're not fighting against, decompilers and stuff like that. You can just mostly go read the source code for a lot of these like cloud natives tools, which is really, really cool.
What would you say is kind of the prerequisite somebody should start learning before kind of getting into attacking it?
Um, I think like a really solid understanding of Linux is probably the only like hard prerequisite, just because Kubernetes is just Linux kind of on steroids. It's everything that happens within Kubernetes is really just a container that's running somewhere. And the actual like Kubernetes part isn't that hard. It's the understanding the underlying like container runtimes and how they're orchestrating things, and what happens if this happens, like where are these credentials being passed. So understanding that. um, Containers are obviously super important. I find a lot of people just think they're small VMs, it drives me a little nuts sometimes. So Linux containers, I would say, I don't think this is a prerequisite, but my kind of background doing like web app pen testing a couple of years ago was really helpful because a lot of Kubernetes is APIs. And so you kind of just understand it better if you understand like how APIs work and that type of thing. Um, and then honestly, just like not even security related, but DevOps, like how these things are used is super, super helpful because most of the time, the hard part isn't like finding some, security flaw or something like that. It's how do I do this? Because there's so many like prerequisite steps that like a DevOps engineer, that's just what they do. But you as a security person, you're like, well, I don't really know how to, deploy these things correctly. And so is this not working because there's a security control or because I don't know what I'm doing when I'm deploying these things? So I would say like the best background you can have is Linux, containers, and then DevOps, and then obviously cloud, stuff like that.
Yeah, I think what I've been limited to is like finding containers that, I mean, I kind of like when you statically compile a binary with libraries that have a vulnerability in them at some point. And then these containers can sometimes have stuff that's outdated getting deployed, and there's things in there that have to be rebuilt and then redeployed securely, right? I guess that's the whole DevSecOps thing.
Right. It's a huge rabbit hole. I think a lot of people they focus at different layers. I kind of like to look at it like the four layers of like cloud native security. So like at the very like bottom, if you look at it kind of like a pyramid, you have your actual like application code, so like your web server, whatever. And then you have like the container layer, which is right above that. So you have like Docker, whatever your container runtime is. Some people are like very, very interested in that. And then above that, you have like the cluster layer, which is kind of the orchestration layer, which is where Kubernetes lives. That to me is something that like very few people ever interact with. And then above that, there's like the cloud layer. So there's a lot of people doing cloud stuff. There's a lot of people doing um, like web app or like traditional like application pen testing. But there's not a whole lot of people doing the containers or the like Kubernetes cluster layer. Um, so it's really interesting.
Nice. Some comments here so far. Use Mac. That's cool. Cool. Yeah, it's. I remember. I don't know. This may be completely unrelated, but for some reason, right when we got started here, I had a flashback to Jason Evans, who wrote J.E. Malik, who I think went to Facebook, and part of the reason they brought him over was to figure out a way to save on just resources in general, with so many containers and things getting dynamically provisioned during busier times and such, and then getting shut back down and all. And
Mhm.
like his allocator, actually, I think he did something crazy around. Oh, I'm going down a rabbit hole. I should probably stop now, but I'll mention what it
Now,
is
now I want to hear it.
in another stream. Where I was going to go, and I've caught myself. So is there's something called dirty page pulling, purging, dirty page purging. And it's like managing kind of efficiency versus security, and giving memory back to the kernel at times of a heavy load. And that's why I'm not going to go down there. So let's get back to what you're talking about. And yeah, so why don't you get started on the, I guess the slides you want to walk us through first would be great. And
Yeah.
as always, I encourage folks, if you do have questions for Graham, please post them up. If it's stuff related to what he is talking about at that particular moment in time, I'll try and interject. Otherwise, if it's more philosophical and things like what should I do because AI is taking over the world, we'll save that for the end.
Yeah, awesome. I'll go ahead and share my screen. While I'm doing that, that reminds me of something I've run into in Kubernetes is there's all these controls for like rate limiting and things like that. Be like, oh, if my container is using too many resources, just kill it and then create a new one. Which is not a security control, but it's very annoying when it's implemented like in like a very strict way. Because if you're running something in a container that's not supposed to be running, and you're using way more resources than it should be, it might just kill it. And you're like, well, what happened? Like, where did it go? And it's because people put like these very strict resource limits to make sure like things aren't going wrong and they're not spending too much money on their cloud bill.
Yep.
So not a security control, but you should probably do it. But it's also you have to pay someone who understands like how these things work. So that could also be expensive. All right. So I have a bunch of slides. My kind of plan here is I have slides and then I have two demos. The first demo is something that everyone can access. I'll share the link for that once I get to it. It's a very simple walkthrough of basically the vulnerability I'll be showing off. And then the second demo is a much more realistic attack scenario of how this might actually happen. I will say when putting it together, there are so many moving parts with Kubernetes that there's all sorts of troubleshooting. And I was trying to like fix everything up and make sure that like I can just run a single, or I have a run book of like every single command that I can run and it just works. And I was like, well, that's not ever how any Kubernetes assessment ever goes. Like there's always some weird like issue. And so maybe it'll work first try, but in all likelihood, there will be like, oh, why isn't this working? Oh, let me go figure that out. And hopefully that will be helpful. Because when I was first starting out with Kubernetes security, I would watch all these demos of like people just running a bunch of commands. And I was like, well, I don't know what just happened. Like I understand the basics, but I have no clue. Like I couldn't explain it back. So we'll walk through that and then we'll have a bunch of time for questions.
Yeah,
So
just a quick shout out. I was, Graham and I were chatting over DM, and Connor and Graham both I'm very proud of, because they really wanted to put in the prep and to make things right. And Graham had asked me, like, do you think most of the people who are going to watch are already going to know Kubernetes, or should we do some kind of a ramp up? I was like, absolutely a ramp up. I think most of us need it. So thank you.
right. I think we'll just skip straight to the end and just come to the conclusion and be like, see, there you go. Cool. All right, so let's go ahead and get started. Just some quick background on me. I'm a red team engineer at Snowflake. That's my day job. Again, kind of like I said before, I do a lot of Linux, cloud, Kubernetes things. I really love researching things, even if that's not entirely useful. Like just the more obscure it is, the better, which kind of lends itself well to Kubernetes because it's mostly just one giant rabbit hole of weird, undocumented shenanigans. Um, in this talk, we'll be talking a little bit about Kubernetes security, just kind of like some basics of it, but then we're really going to dive into a vulnerability that I released a couple weeks ago at this point, where basically the idea was you can get remote code execution in a Kubernetes cluster. And I went through the Kubernetes HackerOne bug bounty process for this, and they deemed it as working as intended, which was a surprise to me and lots of other people I've talked to. And we'll kind of go through their reasons, some of which make total sense, some of which I disagree with. But the good news is that I was looking last night to try to figure out what vendors were still affected by this, and a lot have gone through. And even though it was classified as working as intended, a lot of vendors are not patching, but they're mitigating in a way where they're not. If you deploy their product, they're not vulnerable to this. So that's a win for me. Whether or not it's working as intended, I don't know. You can kind of argue both ways, but that's what this will be about. But before we talk about that, like, what is Kubernetes? Why are we talking about it? Why have I been screaming about it at the top of my lungs for 3 years? So I couldn't find a more updated survey. So the last one I found was the Cloud Native Computing Foundation, which is the cncf.io. They are responsible for a lot of the kind of administrative side of Kubernetes. So they do a lot of fundraisers and they put on events and they get funding and they pay for various security audits and they kind of sponsor a lot of things. And basically they put out a report in 2023 saying 84% of companies are either actively using or evaluating using Kubernetes, which to me was just kind of insane because it was kind of one of those bespoke technologies that you probably have heard of, but you're like, well, maybe there's like a few like SaaS companies using it, but 84% of companies using it or evaluating it is kind of insane for the amount of coverage I think it gets from particularly like the offensive security world. Of those companies, 40% of them cite security as one of the challenges, which if I had to guess, the other 60% just didn't realize how vulnerable they were to some of the things that we're going to talk about. There's a huge lack of training. And then the other interesting thing, and we'll talk about this here in a second, but 28% of companies are using a managed cluster, which we'll talk about the differences, but at a high level, a managed cluster is something where a cloud provider like AWS, Azure, GCP, DigitalOcean, they will manage basically the control plane of Kubernetes. So that's what kind of orchestrates things and makes sure that, applications are load balancing and making sure that, if there's a higher demand, more applications will be launched, that type of thing. So 28% of companies using managed clusters is really enticing to me as someone on like the offensive side, because that means like the majority of people are managing this themselves, which is a terrible idea. You really have to know what you're doing and you have to have a huge team to make sure that you're doing things correctly, because it's very, very, very hard to get things right. So with that being said, if there's any questions, please feel free to pop in at any time. I'll go through a bunch of different things. If there's any questions on like that particular thing, feel free to just throw it in the chat.
Cool.
So this is kind of the thesis of this presentation, is this idea of like show, not tell. One of the problems I have with a lot of like security things is they'll just be like, oh, this has a CVE, therefore you should patch it. And then no one does, and then something gets compromised, and then it gets patched. And so really, I think the whole purpose of offensive security is to kind of demonstrate things, to say, oh, yes, it has a CVE. Oh, and yes, it is very exploitable. And oh, by the way, we stole your, I don't know, your intellectual property or whatever. Kubernetes in particular, I think, is very susceptible to this, because most people don't even realize that it's a huge security risk if they're not running it properly. And people think it's kind of like secure by design, and it has, Kubernetes has a concept of something called secrets. And so if we store things in secrets, then it's secure. They don't realize that secrets are not encrypted whatsoever. And it's just, there's a lot of things that you have to show people before they understand the risks of them, especially in Kubernetes. So I know a lot of people in kind of the offensive security world are more familiar with things like Active Directory. I don't want to compare Active Directory to Kubernetes. They're two totally different things. But the things that are similar are they're kind of foundational to how a company operates, right? So Active Directory is, you kind of can't escape it. Once you're running on it, it's very hard to get off. It does a lot of things. And there's a lot of weird attack surface whenever you have these ecosystems of services interacting. So Kubernetes is similar. It's kind of like, I like to describe it as kind of like the operating system of many cloud environments. And a lot of companies have tried to move away from it, or they're considering it, but they're like, there's not really any other alternatives unless we want to, build something super custom, which some people have done and have been successful, but that's also really expensive. And also maybe the thing that they build is just as insecure. So it's a huge trade-off, building your own thing versus using Kubernetes. I wouldn't recommend building your own thing, but if you're going to use Kubernetes, you have to understand all the risks that come with that. The other problem with Kubernetes is it has a massive ecosystem of plugins or technologies that kind of fit into it. So with Active Directory, you have things like SCCM or SCCM, ADCS, that type of thing. With Kubernetes, the Kubernetes project basically offloads all the kind of core things that you need to do if you're running this in production to third parties. So that's companies, open source projects, that type of thing, which is interesting, except for if you go to this website is landscape.cncf.io, and it's just a big list of all these different projects that you can use with Kubernetes, right? So if you're doing something like a service mesh, or you're using a database in Kubernetes, you can kind of just pick and choose all these various projects, and then those come together to make your cluster. So this is cool from an offensive security perspective, because if you've ever done a lot of like offensive security work, you'll know that the weird issues that you find are really in where systems kind of connect between each other. And when you have all these kind of disparate technologies that are pretty much unique to every environment that you're in, you'll always find things that are misconfigured, or, this service needs these permissions, and this service needs, these permissions, and it's easier just to give everything admin, and then it just works. So there's a lot of attack surface everywhere in Kubernetes. And the other like challenging thing about that is every Kubernetes cluster you're going to look at is going to have some different technology in it. And it's really just something where you have to learn to do almost like vulnerability analysis on the fly of like, I've never heard of this project because it was created 6 weeks ago. Now it's in production. Has anyone looked at this? And you go look at the, the GitHub repos, and it's like 2 people have been working on it. It's like, uh-oh, this isn't good. But that's just how like kind of the cloud native ecosystem works. So are there any questions so far? I know that's kind of like a high level overview.
Yeah, nothing yet. I think, yep, we're
Okay.
good.
So one of the questions I get asked sometimes is like, what is Kubernetes and why would anyone use it? And my answer to that question is basically, okay, like consider this use case, right? Say you're some university and you have to, maybe you have 1,000 computer science students and you want to build a system that basically allows them to use some sort of like in-browser IDE experience. And you want them to be able to complete all their work in this browser, and then they click submit in the, university IDE, and then, that gets submitted and graded. Um, some of the requirements for it are, say, maybe 1,000 students. Each student gets their own isolated environment, so there's no like weird sharing where like one student can access another student's homework, something like that. The other thing is your code must persist between sessions. So if a student closes their browser and comes back 2 days later, the code should still be there. When they log in, they should only see their own work. So they shouldn't be able to, interact with other students' environments. And then the other thing is, TAs or professors need to be able to view the student submissions. So this is kind of a perfect use case for Kubernetes because it's fairly lightweight. You need a lot of instances of this web application that is a browser-based IDE. Um, you need some sort of isolation between these environments. The code must persist, so you need some sort of storage layer. And so as you keep going through this, you're like, I don't really know a better way of doing this than some sort of Kubernetes or container-based solution. Like, sure, you could probably provision everyone their own VM, but that gets really pricey, right? You can run 1,000 containers for fairly cheap. Running 1,000 VMs would be very, very expensive. So that's kind of like a good, easy use case that a lot of people can understand. So when we talk about Kubernetes, there's kind of 3 or 4 main things that you need to understand. The first one is, what is a pod? So the first thing that you'll run into in Kubernetes is this concept of a pod. And you can basically think of a pod as kind of a container for your containers. And what I mean by that is a pod that runs something like a web server is basically running a container on some sort of virtual machine. But a pod can have more than one container inside of it. So say you're, in this instance for the this university, they have, the IDE web UI up here, and then they have some sort of agent that's running as a separate container within that pod. And that submission agent just basically watches the student's directory or waits for something, and then once they're done, it will submit it. Those are 2 totally different applications. One is the IDE, one is just an agent watching some file system. And so you should have those as kind of 2 separate processes, and you should be running 2 separate processes as 2 separate containers. So that's kind of the idea of a pod, is if you want to deploy one of these, you always want your web IDE to have some sort of agent with it. Then you would package those together in a pod, and then every time you deploy that pod, you can be sure that both of those will deploy. So some considerations. I find that most people don't realize this because it's just not intuitive, but by default, these kind of networks of pods are flat by default. So if you are, in this pod 1, say this is, Graham's student container, and you have pod 2, maybe this is like Steven's container, the network for that by default is completely open. Like if there is ports that I can hit from my container and someone else's container, like I basically have, free access to that over the network. So that's already something that most people get wrong, is there's lots of security controls you can lay on top of it, but it gets really complicated. Like normal networking gets complicated, cloud networking gets complicated, but doing container networking within clusters, within cloud environments gets enormously complicated, and it's constantly changing. So that's one thing to watch out for. The next thing that we'll talk about more in a second is pods can be assigned more or less permissions. So you can basically grant a pod what's called the privileged flag, and basically that means it has all the permissions, or you can grant it just the host network permissions, which means it has access to the node it's running on, it has access to its network interface, or there's all these various different permissions you can assign to them. And then we'll dive in deep for the service counts here in a second. But sometimes your pod needs a service count to do certain things in the cluster. So I mentioned pods. Pods are kind of like the fundamental unit of Kubernetes. That's what your application is deployed into. A node is basically the compute resource for that pod. So if I deploy a pod that's an Nginx web server, I'm deploying that onto a worker node down here. And there's two different roles a node can have. So there's no special like requirements for these. You kind of just define, hey, I want this node to be a control plane node or a worker node. A control plane node is basically where all the Kubernetes internals live. And I like to think of it as kind of the brain of the cluster, because everything that Kubernetes needs to orchestrate things and save, the status of the cluster and schedule new pods, that type of thing. All of those processes live on a control plane node. So that's a pretty high value target for attackers. And in a managed cluster, this control plane node is what cloud companies are managing for you. So you don't have to rotate certs on them. You don't have to, do all sorts of manual work to, make sure that things are locked down. They basically manage all that for you, and then all you have to do is use the worker node, which is why I tell everyone, please, please, please use a managed cluster if you can. It's probably like the best thing you can do for your security. So those are the control plane nodes. The next ones are worker nodes. These are kind of the heart of the cluster. So this is where when an application gets deployed, it gets deployed into this worker node, and you can scale these pretty much infinitely. There's lots of different debates about like, should you schedule different classes of workloads on different nodes, right? So should you have a worker node that is only for certain customers, or a worker node that is only for a certain team, that type of thing. And those are really good questions to ask. But this concept of like multi-tenancy in Kubernetes is really, really difficult to get right. And if you have any concerns about it, you really, really need to like figure out what problem am I trying to solve. For worker nodes in particular, I would just say pretty much universally never have like customers or like different tenants on one node. It's going to be a security nightmare, because as we'll talk about here in a second, there's very, very little isolation between the workloads that are running on the node. And when I say workloads, I mean pods and other resources in the cluster. So that's pods and nodes. Together, those make up a cluster. So this is like a very small, simple cluster. You can see there's one control plane node. There's three worker nodes. The worker nodes are responsible for creating, in this example of the student environment, they're responsible for having that web UI that students can connect to. If for whatever reason, say there's an influx of students who are maybe there's finals going on, or there's some big project, you can schedule more and more pods on a node. And then once that node reaches its resource limits by like CPU and RAM, you can just provision a new node and then start scheduling pods onto those. Control planes are a little bit different. Typically in like a production cluster, you would have probably 3. So you would have some sort of like high availability cluster. So if one goes down, things don't completely get nuked. But for the most part, like just assume that if there is a production cluster, you're going to have at least 3 nodes, or hopefully it's running in some sort of managed cluster where you don't have to worry about the control plane nodes at all. So the next part that's important to understand about this is Kubernetes RBAC. So Kubernetes RBAC is probably one of the most confusing topics in Kubernetes just because it's so weird to wrap your head around. So that example from before where we had, these students who need to connect to this browser-based IDE, imagine we had another requirement where we say we got some license from some, AI company where we'll be like, oh, okay, all these students can use this API key to interact with these models, right? How would we get those API keys to those students? In this case, you would need something like a service count, and then that service count would need permissions to retrieve a secret. So in this case, this service count would have permissions to get a secret, so that's a single secret, or, and this is a slight misconfiguration, but a very common one, is it also has permissions to list secrets. So in this case, you'd just be able to not only get your own secret, whatever that may be, but you'd also be able to get every secret in the cluster, which is a super common misconfiguration. And so you can see here on the right, you run the kubectl get secrets, and then you list the namespace, which we'll talk about in a little bit. And then if you pass this -o YAML flag, it will return the actual like YAML manifest of the secret. In this case, it just returns this GitLab token. Same thing if your pod needs to create other pods, which we'll see here in a second with GitLab. In GitLab, when you're creating different runners, it needs to have permissions to create those runners. So a GitLab service count might have a pods create permission. And then right here, that allows you to basically run this command kubectl apply -f. You pass it this manifest file, and this manifest file will be passed to the control plane node, and it will basically take care of making sure that that container or that pod is launched. So now we're getting more into like the area of where this vulnerability came about. So one of the strangest areas of Kubernetes is this thing called the kubelet, which is the process that runs on every node. And basically the kubelet's job is to interact with systems on the node to make sure that containers are up and running. And what that looks like is if you run a command like kubectl get pods, which just lists every single pod that's running, what happens is it will talk to the kubelet, and then the kubelet will talk to the underlying container runtime. And basically the container runtime will tell the kubelet, hey, I have these pods running. The kubelet will send that information back to the control plane node or the API server, and then return that information back to you. But these kubelets are quite strange. So basically they manage the containers on each node, but they also expose an API on this port 10250. And the problem is this is not super well documented. There's been a bunch of people who have gone through and like just looked at the source code to see what's happening. But officially, there's not really any documentation from Kubernetes as to like what's going on here. What is this for? How do we interact with this? Where are the security concerns with this? So one of the things that happens is a monitoring tool that needs access to things like container logs or pulling resources to see like, oh, this pod is using way too much RAM. A lot of these tools will end up using this kubelet port to pull that information because it's the only way that they have to get that information, which has some interesting side effects. So this is what that looks like when you are working Kubernetes. If you want to give a service account or a application permissions to access this like kubelet API, you grant it this nodes proxy get permission. So the resource is kind of what you're giving it access to, and then the verb is kind of the permissions you're giving it. So you can do get, create, delete, list, that type of thing. So the interesting thing that you run into with this is pretty much everywhere else in Kubernetes, when you have a resource that has a get permission, that's something a lot of people just gloss over because there's not, you might be able to read information and you might be able to do something else with that. But for the most part, like in most things, if you have something that's just a get permission, that's mostly a read only. You can think as like a web application. If you send a get request, it would be weird if that was the equivalent of a post request. So basically, if you try to, in Kubernetes, send an HTTP post request, which you can see down here in this curl command, what Kubernetes does on the back end is a little bit funky. It will take that request, and then anything that is a post request, it will check for if you have permissions for create. So right here, we only have get. And so when I send this post request, Kubernetes on the back end will basically translate that to create. And then it will say, hey, you don't have this verb right here of create. And so that's just kind of expected behavior. So this is what that looks like, right? So say you're an attacker, you compromise this pod, you try to make a request that's just a curl request, and you have to send a post request. The kubelet kind of maps that post request to that create verb, which again, we don't have. We only have the get one. So Kubernetes will check, hey, does this person have nodes proxy create? No, they only have nodes proxy get. Okay, well, they're not allowed to do this. And they can't execute their command. So this is where things get very strange. WebSockets is basically a technology in Kubernetes where if you are connecting to something, doing a connection over just raw HTTP is not great. So WebSockets is kind of the go-to for that. And it gives you kind of like more like bi-directional communication. So WebSockets is supported in Kubernetes. And the interesting thing about WebSockets is from the RFC, when it's communicating that initial handshake, you have to send an HTTP GET request first. Basically, you send that GET request, and then it's like, all right, we can upgrade to something else. But it has to start with that HTTP GET, which has some weird side effects within Kubernetes. So the issue is that the kubelet will only check the permissions of that initial GET request. And then it will say, hey, this is an HTTP GET request. Does this person have the GET verb permission for nodes proxy? And in this case, if we look back at this this manifest, we do have nodes proxy GET. So when I run this command, if I'm using WebSockets, it will check that GET and say, yep, this person has GET, and then it will just forward it on. What that means for an attacker is if you are in that same starting position where you are an attacker and you are, communicating with the kubelet, if you were to do so with curl and a post request, that would get denied because you don't have the correct permissions. But when you are doing so over a protocol like WebSockets, because it has to send that HTTP GET to basically upgrade the connection, Kubernetes will check that GET, say, yep, that checks out. You have nodes proxy GET, so you're allowed to do whatever you're trying to do. Please proceed. And then there's no secondary check to say, wait a minute, you're making a GET request, but you don't have the create permission. And so that you can see down here is basically what happens is you run WebSocket, which is essentially curl for WebSockets. You specify some information, and then it will let you run commands in any pod that you want, which is a little bit crazy. And not only does that happen, so you can run commands in any pod, but you can also because this goes directly to the kubelet and not through the normal means that Kubernetes typically uses, any commands that you run won't be logged. So there will be if you have logging set up correctly, there will be um, an entry in the log saying, hey, someone check their permissions, but there's no entry in what was actually ran. So that in and of itself is kind of like a terrifying thought. Basically, the TLDR of this is whatever connection that you make is, or the outcome of your connection is based on whatever transport you're using. So if you're using HTTP, it's denied. If you're using WebSockets, it's permitted, which is a little bit of a scary situation when I don't know any other place where that is the case. So we'll move on here. We have a very simple demo. I'll run through this one very quickly because I have a much bigger demo.
Yeah, I
here
got
in
a few
moment.
questions to queued up if you
Go for it.
want to answer.
Go for it. I'll give people some time to connect to this.
Cool. Yeah, so again, you can play along. Graham put together that link and you can do the lab yourself, which is awesome. Let me see here. I don't want to miss stuff. If I missed your question, please don't feel I'm ignoring you. Please post them back up. Let me find the first one here. So one high-level question, what would be the most common attack surface to look at when it comes to Kubernetes?
I would say the most common one is probably like networking misconfigurations. So people just don't realize that you have to put network controls on your pods. I would say another one is just over permissioned of service counts. There's a constant stream of like people who are just granting admin permissions to the most basic service counts that don't need it. And it's a pretty big problem. And I don't think people realize like why it's a problem, because a lot of people are of the mindset like, hey, if they're already in the infrastructure, it's game over, which is not a great way to look at things.
Nice. I think there might be a Kubernetes expert in the Discord sending me some questions here. So maybe.
Awesome. I'm ready.
In real-world clusters, how often do you see nodes/proxy granted unintentionally via inherited roles, such as Helm charts, monitoring agents, etc.? And does that effectively make this privilege equivalent to cluster admin in practice?
Yes. So good question. Yes, it is essentially cluster admin. Basically, the Kubernetes team has been like, don't grant this to anything you don't want admin. If I pull this up real quick, so there is, in the blog post that I posted about this, if you scroll down all the way to the bottom, I basically pulled all the Helm charts I could to basically figure out which ones were vulnerable to this. I think there was like 70 or something of like very, very well-known products that are using this permission because there are no other alternatives. Like you kind of have to. So these are all the ones that are like using this in some capacity. That doesn't mean if you're running this, you are for sure going to be vulnerable. But if you have certain configurations or you have certain options enabled, the nodes proxy is listed somewhere in their Helm charts. So yeah, it's pretty prevalent.
Nice. We'll do one more, and then I'll give you some time to go through a demo and such. You mentioned WebSockets. What security invariant breaks during the HTTP WebSocket upgrade that causes RBAC verb enforcement to diverge? And where in the request lifecycle would you ideally enforce authorization to prevent this class of bug?
So whenever you're making a WebSockets request, there's a situation in another part of Kubernetes where they basically fix this exact same issue. So basically what they should do is whenever you make a WebSockets connection, it should check that first initial like, hey, do you have authorization to do this? But then it should also check before you are making that actual like command execution request. It should check again after you've negotiated the WebSockets connection, because that will give you the actual answer of, does this person have permission to perform this action. So one right at the beginning is fine, but then you also need one after the initial WebSocket request to make sure that everything is going well.
Well, I'll sneak this one in too because I think it's a quick one. But how would you go about writing detections?
There's some things you can do. So I list some of them in here. There's a script I have where you can run and it will tell you all the service counts that are right here. All these service counts in your cluster that have these permissions. Detection is hard because there's no logs. A lot of things just go out the window. I would say like if you have certain visibility into like what is normal, like obviously having a baseline is best, but like that's really hard to do. So I would say like the best thing you can do is pressure these vendors to like take the alternative routes of getting this information so that you don't have to deal with potentially a cluster admin service account running. That's probably the best way.
Awesome. Great.
So this will be like very, very quick because I have a much more like realistic demo coming up here in a second. But this is like a very quick and easy way to just kind of see it in action. So basically, if you want to come through here and read what each of these things are doing, I'll kind of go through it very quickly. So the first thing is just connecting to a pod called attacker. We're just getting a shell in there. You don't have to do this, but this is like the easiest way to make sure that like you only have these permissions. So the next thing is checking your permissions, and I will make this bigger. Let's see. So checking your permissions, this is the greatest command anyone has ever created, is you can run this and it will tell you everything you're allowed to do. I think every cloud provider, every platform should have something similar. So in this case, these are just default permissions. These are basically saying, do I have permission to check my permissions? So this is the only extra permission that we have is this nodes proxy get. The next thing we're going to do is set up a few things for our actual request. So in this case, we're just setting the service count token for this service count. We're setting that into an environment variable, and then we're going to tell we're going to put the API server into environment variable just so it's a little bit easier. The next thing that we're going to do is we are going to put the name of the node that we're running on into a variable just so we can use that in the request because that will become relevant. And then this next one is clear my screen. You run this command and you're basically just running wget and then you're using JQ to parse the output. And this basically tells you everything that's running on your cluster only using the nodes proxy permission, which is already like super useful for enumeration. And then the next thing that we're going to do is extract the IP address for the node that we're on. In this case, it is this 172.16.02. And then you run this command. So this is the WebSockets one. Basically, you run WebSockets, and then you provide the path here. If you want more information on what this means, I go pretty in depth in the actual blog post. But basically, you're just specifying which container you are trying to run commands in. So in this case, you run the ID command, and then it returns, hey, you're running as root, which the root part isn't actually interesting. Most containers run as root. They shouldn't, but they do. But the actual interesting thing is that you're running commands in that container. And then just to prove that, you can also read the contents of things like Etsy shadow and things like that. So that's kind of the like quick and dirty demo to see like how these things work. If you want to run another command, so this is the same command I was showing earlier, where if you run this with just a post request, you can see it's the same endpoint. Oops. It's the same endpoint, but in this case, we're denied. So depending on which transport you're using, HTTP or WebSockets, you'll get a different response there. So that's the quick demo. Any questions there?
Yeah, a couple of them. I got a question myself. I posted it up.
Sure.
Do you think it's the ethical decision for maintainers of Kubernetes to not patch simply because the large number of deployments dependent upon the current behavior?
Um, it's a hard question. It's like I get the argument of, well, this is just kind of like bad, but like a lot of people are using it. But in my mind, that's more of a reason to patch it if a lot of people are
Right.
using it. Um, I think the real issue is that there is no current alternative right now. And if you look into the blog post, there is a proposal for an alternative. In Kubernetes, they call them KEPs. It's like the Kubernetes enhancement proposal. This KEP has been around for a long time to basically try to address these exact issues. Let me see if I can find it real quick.
Kubernetes group got its own vernacular English, you know. Oh.
That's right. That's right. So they have a proposal to not fix this, but to introduce new permissions that would make this one obsolete. And so I think it's good, but it's like this is going to be useful for me for years to come because like it's going to take many, many years for that to get. It's not even out of beta right now. So
Yeah.
Yeah.
One other question was, where should authorization actually live in Kubernetes to prevent protocol upgrades from changing the security decision?
So everything in Kubernetes, well, for the most part, things in Kubernetes, the authorization, and there's a few caveats to this, but the authorization lives at the API server. So if I go back to a picture of this cluster, so this is like the control plane. The API server is, for the most part, making a lot of the authorization decisions. That's also where the logging happens. So the issue is that if you're communicating directly with like kubelets, you're not communicating with the API server. So really, like everything should be in the API server. I don't think that's feasible. I think they probably would have liked it if it was designed in that way to begin with, but like I don't think there's any going back now. But that would be ideal.
Nice.
Any other questions?
Let's see here. I know I saw some. Yeah, Emmanuel asked, did you find this by looking at that proposal, or how did you find this one out? Like, what was your approach?
So I found this because I was looking at something different, and I ended up finding a separate vulnerability that was a denial of service. And the reason I found that is because I typoed a command and it crashed. And I was like, what just happened? But like I didn't have time to look into it at the time, so I just like tabled it and came back to it a few weeks later. And when I was investigating like why did this thing crash, I was like, wait, this thing shouldn't have even been authorized to do anything. How is it even getting to the point where it's crashing? And that's how I ended up finding this one. And then I went back and I found all of these other issues with this like nodes proxy thing and that KEP and things like that.
Awesome. We'll have more coming soon.
Awesome. All right. So this is basically just the diagram of what we just did in that lab. Fairly straightforward. The attacker gets access to a pod somehow. They gather some information, and then they run nodes proxy, or they use nodes proxy to basically run commands in another pod. That's all well and good, but that's not a realistic attack scenario. So we just did questions. So we'll move on to a realistic demo. This could take like a month. So like I'm going to run through this fairly quickly. But if there's any questions, then like feel free to stop me at any time.
Cool.
So for this next scenario, instead of that kind of student environment where they're running these different VMs or these different containers for their students, in this case, it's a company who is running Kubernetes for basically CI/CD pipelines. So whenever their developers push code, maybe the CI/CD pipeline automatically builds things, deploys things, does some sort of linting, checks for secrets, that type of thing. This is a pretty common use case for things like GitHub or GitLab to use Kubernetes to basically spin up containers that does one thing, and then the container dies, and that build artifact is, moved along the pipeline. So that's the scenario we'll be working in this this example. So this is kind of what we're going to be doing. I'll back up here real quick, and I will share the rest of my screen, and we'll kind of go through this step by step. Let's see here. So I will go ahead and share my screen. And then let me get things situated here. All right. And then you should be able to throw that up. All right, perfect. So I know this is going to be really, really small. Give me 1 second. I will fix that. So, all right, is that legible?
Well, yeah, the top is, sure.
Okay. So to get started in this kind of like scenario, we have this example GitLab repository. In this case, like just imagine this is some application a bunch of developers are working on. There's something that's happening in this repository, right? So we as a attacker get access to maybe someone's endpoint, or we somehow get access to push changes to this repository. So the first thing that we do, and I've already done this because it can take some time, but in GitLab, you have this kind of continuous integration file, and this kind of defines how things are going to be run. In this case, we're basically just saying, hey, we're going to have 2 stages. We're going to have a basically a script that runs every time something is pushed to this repository. In this case, as the attacker, you would update this and you would put whatever it is that you're trying to do. In this case, we're going to say, hey, we want you to call back, or we want you to reach out to this this S3 bucket, and we want you to download and execute this binary, which is like, it sounds very malicious, but that's also like how updates work. So you could just say, hey, I'm pushing a change to update, bump the dependency version on this or whatever. So we're going to come in here. We're going to make a simple change. Right. So that's all we did. We'll do a git add readme, updated readme. So what this is going to do is, as soon as I push this change to GitLab, there's going to be a few things that happen fairly quickly. So the first thing that's going to pop up is, let's see, where is it? So I'll come down here to the pipelines tab, and you'll see these are past pipelines that have ran. So you can see I was testing things. The second I push this, GitLab will pick it up and start to run that job that we had in this GitLab file. So I'll do a git push. And then you can see, okay, that pushed just fine. And then this starts popping up as pending. And you'll see it starts to build those jobs. If I switch back over to Mythic, which is just like an open source C2 framework, you'll see here in a second, I'll get a notification saying, hey, you got a new callback. And basically what that means is the change was pushed. There it goes. So the change was pushed, and it was that GitLab runner that is supposed to be building something within GitLab. Maybe it's building the actual code, or it's doing something like linting. It's running our custom code as the attacker. Again, that custom code is just this GitLab like CI/CD thing that reaches back out and grabs the implant, right? So we have that callback. So now we have access to the shell within that GitLab runner. So we'll go ahead and set the sleep to 0. So this will update every second. And let me pull up my notes here because this gets really complicated really quickly. That's the other thing, is if you're doing Kubernetes assessments, everything sucks because you're dealing with so much output. Like you can run a command and get 20,000 lines of output of JSON or something like that. So that's terrible. The other thing is there's so many really long, complicated commands that you need to just have somewhere that you can copy and paste in. So we have access to this. I'll just change directory to the root directory, and then just to show you that we have access, here's everything that's running in that pod. So one thing that you kind of do in a lot of tests is you start looking at the service account tokens. So remember we talked about Kubernetes RBAC? So those tokens that are in those, or those permissions that are assigned by those service accounts, they are kind of injected into pods via these service account tokens. So if you take a look at this, this is fairly standard on a lot of like Kubernetes environments. It will put the secrets or the tokens in this section or in this directory. So if you grab this, which this is just a JSON web token, and then the next thing I do is I put this into a token variable. You'll work a lot with variables in Kubernetes just because, like, just pasting this in manually is a huge pain. So I will set that as a variable. If I echo token, I get that back. The next thing I do is there's this handy command where you can basically base64 decode this JWT. So you run that. There's not anything super sensitive in here, but I like to look at this because it gives me interesting insight into what's going on in the cluster. So in this case, we didn't talk about namespaces too much, but I'm running in this GitLab runner namespace. This is the name of the node that I'm running on. And it's just helpful for like context is to see like what's going on here. Like if you're, running as a service account that's called cluster admin, you probably have a pretty good idea of what you're able to do. So the next thing I'm constantly doing is I always go to the temp directory just so I have a nice area to work in. And then pretty much the first thing I do is whenever you're working in containers, you have a very, very limited set of utilities. So in this case, I have wget, but I don't have kubectl, which is the binary that you use to kind of interact with Kubernetes. So I'll just run this command to download the kubectl binary. And you'll see I'm putting shell in front of everything. That's just because that's how you interact with things in Mythic. If I were to run wget, it would say that's not a real command. So shell basically just means you're executing a shell on the host, which is then running wget. So that has downloaded. The next thing I'm going to do is just make that executable. Again, there's like a weird way in Mythic to do this, but essentially I'm just saying that file I just downloaded, make it executable. And then here's the fun part. I get to use kubectl. So I'm going to run shell and then kubectl. Again, this is the greatest command that anyone has ever implemented in any system, is the auth can I list. By default, we looked at this file right here. By default, Kubernetes will use this path anyway. But if you want to make sure that you're using the right service account, you can grab that again and then give it the token variable or a flag and then paste that in. Again, this is what I'm talking about with like everything in Kubernetes sucks to work with because it's so much output. But running kubectl auth can I list, which should give us back what permissions we're running with. So again, this looks terrible. Let me make this a little bit bigger. So you can see here, this output is very scary because we have permission with this service count to create pods. We can also create, get, and update secrets, which is interesting. We can attach to pods, which basically means we can connect to them. We can get service counts. There's a bunch of interesting things here, but for the sake of this, I really just want to focus on this pods create and kind of what we can do with that. So there are other things that we won't touch on that you can do with that. That's probably a faster path to cluster admin, but in this case, I want to show off the nodes proxy permissions. So where are we at right here? Let me pull up my slides again. So if we take a look at this, we are basically, we were here, we pushed code to GitLab. The GitLab runner started running our code. It then downloaded and executed our payload. And then we have discovered that there is a service count in this pod that has create permissions. So next, not to spoil it too much, what we're going to do is we're going to abuse that pods create permission for somewhat nefarious things. So let me put my notes back over here. So how do we do that? There's a few different ways you can do it. Some of them are easier than others. But basically what we're going to do is I have created a nifty directory in here that is just called upload. And I have this YAML manifest that is just called implant. Basically, what this is going to do is it is going to create a pod that is just called breakout pod. And it's basically going to grant it every possible dangerous permission, just because why not? In real cases, you don't technically need a lot of these, like privileged. But the big thing is it's going to also download our implant and run it. So I'm going to use Mythic to upload that. And I will upload implant.yaml. And then I will send that. So that has been uploaded. It is now in the temp directory. So if I do a kubectl, let me put a shell in front of that, kubectl apply -f for implant.yaml. Did I get that correct? I think so. So that will say, okay, I just made a pod for you called breakout pod. And then we can verify that by saying kubectl get pods. And you can see here, I got a new callback, and I'll talk about that in a second. But this was the breakout pod that we just created. And remember, in that YAML manifest, we basically said, hey, download the implant again. So now we have another implant running in that pod. What good does that do us? We're already running in one pod in this cluster. Why would we need another pod? So in this case, the thing we want to look at are these. So there's the mount path, and then there's the host path mount. And basically what this is going to do is this is going to create a directory on inside of our new breakout container. It's going to create a directory called host, and then it's going to take the host file system of the node, and it's going to put it inside that directory. So basically what that means is if I come to our new implant and I set the sleep to 0, and you can see here I'm just in the root directory. If I do an ls, I'm in the root directory of our new pod. But if you'll notice, there's something here that is not standard, which is this host directory. So if I go into that, and then I do an ls, you can see now there's another root file system. This is the root file system of the node that we're running on. which is basically we've just broken out of our pod, because now that we have access to our host file system, we could do all your standard Linux things. We could add SSH keys. We could, just peruse the file system for secrets. We could look for Kubernetes specific things. Whatever might be on there, we can access. So that's cool, but we want to use nodes proxy to do some shenanigans. So the next thing that we're going to do is we're going to take a look at this directory that is essentially, because all these containers are running as, or all these pods are running as containers on these nodes, the files have to live somewhere, right? So if we take a look at host, so again, we're going into our nodes file system, host var lib kubelet pods, and we just take a look at that. You'll see that there's all these kind of like random directories that are like just like a big GUID, right? And so basically what we want to do is just start perusing that. Like what is in this directory? So I'll just copy that, and we'll see all these different files here. And what we're looking for in here is this volumes directory. Volumes. Because this volumes directory is where Kubernetes injects those service count tokens. So we will run this again, keep looking in those. Let's see. Volumes. Copy this. Okay, so that one just doesn't have a service count, but some of these do. I won't spend too much time going through and looking at all these if there's not one I can find quickly. Let's see. Maybe this one. Again, there's no like rhyme or reason as to what these are called. It's just kind of trial and error. So we'll take a look at that, and then we'll look at volumes. Anything in here? Okay, we have a projected volume. Grab that. Anything in there? Yes. So you can see in this case, there's other things that are in here. And these, if we keep going deeper into this directory, you'll see there are secrets in here. This token is the same service count token. So if we actually cat out this file, we can basically access the service count token that is running on here. So that's super useful, but like doing that by hand is a huge pain. You can see how long that took just for a single one. So you can kind of automate this by doing this little enumeration script that is conveniently called enumeration.sh. And then we'll mark that as executable. That has been marked as executable, so we will run it. And basically what this is going to do is that manual process we did of just like basically walking the directory to find all the service count tokens. This is just going to do it for us, and then it's going to list out the token here. So what you should do is just like come through here and try all of them. I'm just going to grab this service count token just for the sake of time, so that we can start using it. So this service count token is for this Prometheus server service count. And because I set this lab up, I just happen to know that that is by default has nodes proxy. Notably, it no longer has nodes proxy because a few weeks ago they flipped it. And I looked at the GitHub issues, and it was cool. Someone had mentioned like, hey, we should probably fix this. And they did. So that was cool to see. So we will grab that service count token, and then we will run kubectl auth can I list, and then we'll give it the token that we just grabbed. So again, this is running as the Prometheus server service count, and we'll run that. And let's see. Oh, I have to. So I'm in a new pod because remember I created that that new one, so I have to re-download kubectl. So let me do that. And then path kubectl, mark it executable. And then I will now rerun that. And you can see here that this, if I make this a little bit easier to read, this service account has our nodes proxy get permission. So that's cool. How can we exploit that? There's a few different ways. It's a little bit easier to do it if you just have normal SSH access. The problem with using WebSockets is Mythic freaks out and it won't display things properly because you're doing all sorts of weird like session upgrades and things like that. So what I like to do is I just like to upload this file. So I have this file called exploit, very convenient. Basically, it is just going to run WebSockets in a way that is easier for Mythic to handle. And then I will mark that as executable. So we set that as executable. If we go ahead and run this, it's going to ask us for a few different things. So if we run that, it will say, hey, we need these different parameters. And these parameters are basically just parameters that you can get from nodes proxy. But because our service account token has other permissions, we can actually get those in an easier way. So instead of running auth can I list, we will run get pods -a. So that's going to be across all namespaces. And then we were going to say -o wide, and that's just going to give us a little bit extra information. So as this like Prometheus monitoring tool, we basically just listed all the pods that are running in the cluster, which is already not great. And then I want to look for a pod in here that is running as privileged. So where we're at right here on our diagram is we're almost at the end. We've basically just discovered we have nodes proxy, and now we want to exploit that to run other commands in another node. And so that's kind of the impact of this is you can run commands not only on pods on your node, but you can also run them on pods in another node. So if this is an unmanaged cluster, there's nothing stopping you from running this on the control plane, which is pretty much like the worst possible thing. You can do basically whatever you want. So that's just kind of some context as to where we're at. We're like 2 steps away. So we are going to look for a pod that might be privileged. And the reason we're doing that is because a privileged pod has permissions that normal pods don't. In this case, we'll be able to mount the file system of the node into the pod itself. So I'm going to look for one that is probably privileged, and I also want to be on a different node than the one I'm on. So you can see up here in the host, our host is this ends in KD in LT. So I want a pod that's not on that one. And this one looks like a good target. So anything that's a CSI is like a kind of a storage node. So this one seems like a good target. So I will copy this. And then I will run kubectl get pods. And then I just want information about that one. But then I also have to specify the namespace it's in. Cube system. So we're getting a pod in cube system. The name of the pod is this, and we're just getting a little bit of extra information on it. Okay, so in this case, we got that. And now that we confirm that works, we are going to replace this O wide. So instead of output wide for more information, we're going to do O YAML, which will basically give us the entire configuration of this pod. So we can come through here and we can start looking at the information that we need. If we go back to this exploit command that we ran, we need the IP, the namespace, the pod name, the name of the container running in the pod, and then whatever command we want to run. So in this case, I will run yet another command. Let's see if I can grab this real quick. So we got the YAML, but I really like this is just too much information to parse through. And so I will run this command, which will basically do the exact same thing, except for we're going to basically specify that, hey, we only want like this particular information. And I'm going to make sure I'm doing that on the right one. All right, and then I will fire that off. See if that comes back. Let's see. All right, so this basically just gives us the names of the containers running in the pods, because remember, pods can have more than one container. In this case, you could try both of them, but I want to target this csi.do container, which is the one that actually has more permissions. So we are going to run, let's see. Let's start kind of cataloging some information here. So we got the, let me see, we got this information. So we have the name of the pod. I'm just going to write this down over here. We have the name of the pod and we have the IP address. And then in this command, we grab the name of the container. And I think that's all that we need. So I will run this again just to see what else I need. So the IP address from that pod was 10.128.0.2. The namespace was cube system, which is kind of like the admin namespace. The name of the pod was csi.do.node 2xwp9p. And then the name of the actual container was csi-do-plugin. And then this theoretically should work if I didn't make any typos. Let's see. Let's try to run ls. Okay, so our environment variable wasn't set. So we need to tell, basically tell it that we're running with this, this Kubernetes service count token. So let me grab that. Kubernetes is just a game of who can copy and paste better, I think.
Yeah, the demo gods are always watching too, so.
I know. So we'll set the token just in environment variable, and then we'll run that same, actually, I think this needs to be after shell. So we'll run shell, set the token, that token will get passed to our tool. We'll fire that off, and shell not found. There's two shells. All right, fingers crossed. All right, so now we've run another command in a pod in a different node. So we've gone all the way through here, gotten up to here, got the pod. Now, one last command that we have to run just to prove that we have access to the node file system. Instead of running ls, we'll run mount, and we can see the output returned. In particular, we are looking for a way for us to mount the host file system of the actual node. So we will replace the mount command with this one. So we're going to make a directory called host root, so the root of the node. And then we're going to mount this dev VDA1, which is the node's file system into that directory. And then let's see if that works. I should probably make that directory first. Do one command at a time here. All right, so we'll do that, and then we'll just run mount. And then no output, so maybe that's a good thing. And let's take a look at that directory. All right, and we see another file system, but what does that mean? So if we go to etc hostname, and instead of ls, we will cat, just to prove that we have access to it. So that is the host name of the other node. You'll notice we are running on this node right now. Just for further proof, we can do sc shadow. And we have root access to this other node. So that completes the final step. And so now we've gone through, we've gotten access to this runner, created another pod from it, found a service account with node's proxy permissions with only what is supposed to be read-only permissions, exploited that using WebSockets to launch commands in another pod, mounted the file system of the node into that pod, and now we have root access to that. So that is it. If there's any questions, I don't know how much time we have, but I'm sure that was incredibly terrifying for someone who's never looked at Kubernetes to be like, what just happened? So I'm happy to stay on as long as necessary for any questions.
Cool. Yeah, we're at 1 hour and 15 minutes, almost an hour and a half now. Like I said, Conor McGar sets the record at like 2.5 to 3 hours, so we don't have to go that long.
Right.
No, great. That's really, really cool. And thank you for doing that demo. I guess, do you want an easy question first or hard question first?
I'll go with easy. Yeah.
The easy one's the most recent. If you had to put a number on it from 1 to 10, how big of an issue is this? How many exposed systems and how easy is it to pull off?
It's a hard question to answer because of just the way Kubernetes is used at different companies. Some companies just use it for very basic things where it's just running internal tools and it's not that big of a deal. Some companies use it, I don't know who came up with this, but they deserve a medal for it, called RCE as a service, where you launch something and then they just run it for you. And that's their entire business model. For that, it's a much bigger deal. I would say it's pretty easy to exploit. It also doesn't leave any real logs of what happened. So I don't know, it's hard to tell because so many companies are running it differently. I think it's a much bigger deal if you're running in a cluster where, say, you have your security architecture relies on, like, say you have customer 1 on node 1 and customer 2 on node 2. Now all of a sudden that is a really big issue if customer 1 can access customer 2's data in a way that's not logged and not intended. So it really just depends on where you're running and kind of what you're doing with Kubernetes.
All right, let me find. I guess we'll do that one first since it just popped up. Is this more of an internal or external problem?
It can become an external problem, but it's mostly an internal problem. The issue that you run into is that just because someone gets access to, in this case, a GitLab repository, doesn't mean they should totally compromise every piece of infrastructure you have. It could be an internal one if you have a public GitLab repo that you're allowing people to modify and they can somehow modify those CI/CD pipelines. Then all of a sudden, some random person can just, be in your infrastructure.
That sounds like a great way to maintain access once inside.
Right. And honestly, like from the people I've talked to who do incident response, good luck like kicking someone out of Kubernetes because it's basically, I don't want to say impossible, but it's very, very difficult to be sure that you've kicked someone out.
All right, here's a hard one. I think it's hard anyway. At what exact point in the API server to kubelet streaming pipeline does the authorization decision become frozen, and would enforcing a second authorization check post protocol upgrade after SPDYW WebSocket negotiation actually eliminate the vulnerability, or would connection identity reuse still allow privilege confusion? Wow.
Quite the question, but a good one. So if I understood correctly, it's like the question is, at what point would a second authorization check be helpful? In this case, this is where like I had the same question when I was trying to figure out what did I just stumble onto, and I basically had to go through the Kubernetes like code base and figure out what was happening. And so if you come through here, this will probably answer your question much better than like I could verbally. But there's kind of two bugs here. There's this one where it's basically saying, hey, you sent that initial request, and it's an HTTP GET, so you're good. And then the second bug is the resource in the kubelet that is responsible for actually like executing this command. It's missing from this part of the code. So you can see there's all these other endpoints here, but there's nothing for the exec endpoint. And so there should be like multiple levels of places where you can say, hey, we need another authorization check, or we need something besides what we have. There was another spot in Kubernetes where they did this in the actual API server. I get that it's like a very difficult thing to do, but I don't think anyone was using nodes proxy get in a way where they thought that they were executing commands, because that's just not how Kubernetes works. I would be very surprised if anyone was actually legitimately doing that.
Nice. Yeah, that was a good question. Whoever asked that one.
Yeah, that was intense.
When I saw it pop up, I was like, "That's got to be a tough one for Graham." Well, not too hard. I know you knew the answer, but yeah. All right, let me see. From Mac, what level of access should a tester realistically have when assessing a Kubernetes environment? Some teams often say, "You only found that because we gave you access."
Yeah, I say whatever access like developers have is generally like a good start, and it's usually not too difficult to grant that. There's a few different ways you can approach it. The first being if you are just a normal developer and you have, some way to break out of those expected capabilities, that's always a good place to start. Another one is like, and this depends on what you're doing with Kubernetes. If you're just using it to run like linting jobs to make sure that like everyone's code looks okay, then like that's different. But if you're like a bank and like this is how you're like sending money around the world, like you should probably be testing things from multiple different job roles. So like the DevOps engineers, like any site reliability engineers who are responsible for doing this. And for those, like a lot of them will be cluster admin, but you're also looking for if this person was paid $50 million to do something suspicious, would we be able to figure out what they did? I don't, it's very, very hard to answer that question in Kubernetes because logging is really hard and there's not a lot of like information out there of what is interesting to look at. So that's what I would do. You can also kind of go like the code review route where you basically get someone to dump all the like YAML manifests in the cluster, and then you can kind of like statically review them to say, hey, this manifest has a permission where someone can list all the secrets. That's bad. Not super fun, but it's like a pretty simple way where someone can just run a command and then send you the output and you can review it.
Nice. Same person who asked a technical question a moment ago just DM'd, and I'll just share their username is it's Kate, not Kate. So it's KATE, not K number. Yeah, that's
nice.
Username. Follow on. Thank you for the answer. Is the real vulnerability that Kubernetes authorizes transport initiation instead of capability invocation? And does that imply other upgrade-based APIs may share the same confused deputy problem?
Yes. So that is the core issue. It's authorizing what actions you're allowed to take based on the transport that you're using. So there's a lot of like interesting, weird things happening within Kubernetes. There's not just WebSockets. Someone mentioned Spidey earlier, the SPDY protocol, which is just like it's I am very surprised it's still in Kubernetes. Um, I don't know for sure if it has the same like issues. My guess would be it probably doesn't do the same thing that WebSockets does with like having to send the initial GET request. But like there is a lot of attack surface with these other weird protocols. But yeah, that's the underlying issue is it's authorizing it based on the transport.
Nice, great. I think that that captures everything. Oddly enough, surprisingly, no one asked a question on what your thoughts on the future of AI's impact on cybersecurity roles. So if you want to answer that, you
Oh
can.
man, I was ready for that one because I feel like that's everyone's question. I don't know at this point. Like 2 years ago, I would have been like, it's like a fad. It's you know, fancy and it's cool and it's helpful, but like whatever. But now things are getting like kind of weird, where like things are really, really helpful, and I'm actually doing my master's thesis on this of like how can red teams use AI in a way that's not like stupid. Obviously, it's not the official title, but that's kind of the way I'm thinking about it. But like there's all these people who are using like these AI tools for like automated pen testing, and they say like the joke I have is like they say, "Hey Claude, like go run Nmap," and like that's fine, but that's not super useful, and that's probably like borderline irresponsible. So like the way that I've been using it is very different. I will say if you're writing Kubernetes like YAML manifests, please don't write that by hand anymore. Like it is so much more efficient to say, hey, I need a Kubernetes manifest that does, um, creates an Nginx pod and it has, um, like these properties. Obviously, you still have to review it, but like that is much, much better than manually going in and like making sure you get all your spaces right and like stuff like that. I will say what I've been using it for is very much like things like this. So there's all sorts of like JWT decoders out there, but none of them are like tailored towards like what I want. So like I just very quickly like I don't do web development, right? But I just go through here and be like, oh, I need to decode this. Instead of pasting it in my terminal, I'll just paste it in here and then it will automatically decode it for me and then like grab commands down here of like, hey, as this service account, what can I do? I just click copy. And that saves me, I don't know, 30 seconds. But it also didn't take me any time to create this. Also, there's no risk of like, you know, this being stored somewhere and like whatever. Like I refresh it and it's basically gone. So like I've been using it a lot for things like that, where it's like very like helpful tools or like writing manifests and things like that. And it's very helpful, but I don't think it's going to get to the point where it will replace anyone. It might make some people think that they can hire less people, but I don't know if that's a great idea either.
Yeah, yeah, good thoughts. I mean, it'll be interesting for sure. I mean, we all know how greedy CEOs and such can get to appease the shareholders. So if they see an
Right,
opportunity to cut down streams and save costs, obviously
right.
but I think that some who cut too deeply will realize they cut too deeply and have to fix it. And I think that I mean, I don't know this, but I just imagine, just like we saw the other day with the malware inside of a open claw script or whatever it was, like
Hmm.
I imagine that with all this stuff being pushed out and excessive agency and access to file system things we would never think of before to allow AI products onto there, that there's going to have to be some serious incidents at some point, and that's going to spook some people, slow things down, and also the regulatory and governance and just that whole environment like that hasn't caught up. To hearing as a director, as a manager, as an executive, hearing autonomous agents or agentic red teaming running on there without the ability to necessarily reel in the scope or have that trust that you can, even though people say, oh, we can put the guardrails that allow it. We'll learn a lot.
Good luck. Yeah. I don't know, it's getting like a little scary with like how capable some of the things are, but like to me that is I'm not at the point where I'm like, oh, like this might take my job. I'm like, oh, this will make it so much easier to like do things during like a red team or like say I've never interacted with this technology before. Now it's very, very easy to like quickly spin up some tool that, parses the API responses or um, does some random little custom thing that would have taken me 4 hours before, but like now I can do it in 30 seconds. Like that's super useful. Um, and maybe the people who are like already doing these types of things are going to just be so much more productive and like maybe, but I don't know. It's very weird. I also heard someone make the argument that if everyone, and I don't know if this is the case, but if it did make everyone say 20% more productive, wouldn't you just hire more people to that are just more productive? Like you wouldn't necessarily reduce your workforce by 20%. Like if you could have the same effect for everyone. I don't know how true that is, but I thought it was interesting.
Yeah, some of the cuts obviously just don't even seem to. I mean, I can't speak for it, but you saw like Verizon a couple months ago laid off like 15,000 plus people when the new CEO took over, and obviously that hurts. And um, I think some of the decisions aren't really factoring in security and all the impact and such.
Yeah. Yeah, it's very weird. I tried a new service the other day by the guy who founded GitHub made like a new, it's not a new GitHub, but it's like a new product that's kind of like GitHub, but for like it manages like AI context and stuff. And I was like, well, I'm gonna see what this is. So I tried it, and by design, it just like pushes all of your agent like conversations to GitHub. So like not just your prompt and like what you said, but also the responses. And they're like, oh, well, we do filtering for like, API keys and stuff. I'm like, I'm sure you do, but like there's a lot of like sensitive things in there that aren't necessarily like an API key.
Yeah, until
Like,
you say base 64 the API key, and then they don't see it.
right. I'm like, this is terrifying, but like good for me because I work in security, but like I work on the offensive side. So
Yep, yep. Cool. All right. Well, I don't see any more questions, and I think that was really, really cool stuff. I expect others to reach out to you to say, "Hey, we saw you do that stream. Will you do it on my stream too?" But
right.
amazing work. I mean, it's super cool. I learned a lot. Thank you so much for putting together the little kind of way in which people can go to the link and try it out for themselves and everything. And
Hmm.
be on the lookout for some questions on the YouTube page for follow up. I'll let you know if you
Awesome.
see a bunch.
Awesome. All
All
right.
right.
Yeah, this was super fun. I really appreciate it.
Yeah, and have a great weekend. Everyone, appreciate it. I'll announce some new streams coming up soon, and we will see you next time. Thanks. Bye bye.
Thanks, everyone.